Welcome friends, welcome to this lecture series, and in this lecture series we are discussing many of the important topics for your GATE examination. And in today's lecture we are going to discuss another very important topic for your GATE examination, that is stopping sight distance, and we will be seeing that what type of questions they ask from this stopping sight distance in your GATE examination. Very important topic. Every now and then they repeat questions from this topic, and therefore we should cover this topic and go for the GATE exam. Okay. So we're going to study in this lecture. First we'll study what is the lag distance, then we'll study what is the braking distance, and then we're going to study what is the stopping sight distance. Yes. And before starting the class, please join this Telegram group, because in this Telegram group I'll be sharing more lectures, more notes and questions and guidance for students. So you can join this Telegram group. Okay. Now let us start with what is stopping sight distance. Let us start with stopping sight distance, and what is this lag distance, what is this braking distance. Let us understand them. Okay, what is this lag distance, what is this braking distance, let us understand them. So stopping sight distance, stopping sight distance. So as the name suggests, sight distance means what? The distance which is visible on the road. Yes. So sight distance means what? The distance which is visible on the road, such that when you are seeing an obstacle on the road, you are able to apply brakes and stop the vehicle before collision. Okay, you are able to apply brakes and stop the vehicles before collision, so that there will be sufficient distance to stop the vehicle. Now, how we calculate this stopping sight distance, which is in short known as what? SSD, which is in short known as what? SSD. Yes, short known as what? SSD. Let us start it. Just give me some time. So sorry for the interruption. Okay. So now you see what I told, this SSD is what? Is the distance required to stop the vehicle without collision with an obstacle. Yes, collision with an obstacle. So suppose this is our road, this is our road, this is our road, and suppose here we have a obstacle. Suppose some stone is there, or some tree has fallen, okay, or something has, the broken vehicle is there. Okay, now suppose here is, we are traveling, suppose we are traveling in a car or some other vehicle. Okay, so now we are spotting this obstacle. So when we spot the obstacle, then, or the driver spots the obstacle, the driver is not going to stop immediately. Why the driver will not stop immediately? Because the driver will take some time to stop the vehicle, means to react to that thing, right? The driver will see the obstacle, but the driver is not going to apply brakes suddenly. Why? Because the driver is a human being. Yes, the driver is a human being. So the driver will take some time to react. That is known as what? The reaction time. And during that reaction time, what will happen? The vehicle will move forward. Obviously, because the driver is taking time to react, the vehicle is not taking time to react. So vehicle will move forward in that time. Yes, the vehicle will move forward in that time. So this distance which is covered during the reaction time of the driver, this distance is known as what? The lag distance. This distance is known as what? The lag distance. So what is lag distance? I can say this the distance traveled during the reaction time of the driver is known as what? Lag distance. This is the distance traveled during the reaction time of the driver known as what? Your lag distance. And how to calculate this? Very simple. Suppose the driver is moving with the speed v, okay? So, and during the reaction time also it is moving in the speed v. So what is the distance? Distance is speed into time. So I can say here the lag distance will be equal to, I can say here the lag distance will be equal to, your speed into time, and this is the reaction time t. This is the reaction time t. This is the reaction time t. Now the reaction time t will be different for different drivers, right? It will be different for different drivers. But there has to be a standard value. So Indian Road Congress IRC recommends that this reaction time t should be equal to what? Should be equal to 2.5 seconds. So this is the standard value. So if some other value is not given in the question, we'll take the reaction time as 2.5 seconds. But if some other value is given, suppose 3 is given, so we'll take 3. If some other value is not given, it's not mentioned in the question reaction time, then we'll take reaction time is equal to 2.5 seconds. So this is the reaction time 2.5 seconds or t, and this is the speed in meter per second. This is the speed in meter per second, small v. Now suppose I am mentioning the speed in capital V, that is in kilometer per hour. That is in kilometer per hour. Now if I want to convert the kilometer per hour into meter per second, how I am going to convert? We know that this is in kilometer per hour. 1 kilometer is 1000 meter, right? And then 1 hour is 3600 second. So this 0 get cancelled. When I divide by 2, then I'll get a 5 here, I get a 18 here. So when I multiply 5 by 18 with this speed in kilometer per hour, I'll get the speed in meter per second. So I can say 5 by 18, the speed in kilometer per hour is equal to the speed in meter per second. So this lag distance which I have written here, small v into t, I can also write this as what? I can also write this as 5 by 18 capital V into time t, where this small v is equal to 5 by 18 of capital V. Small v is meter per second and capital V is kilometer per hour. So this is the lag distance. So I can say if I want to define lag distance, okay, if I want to define the lag distance, so what is lag distance? Lag distance is the distance covered during the reaction time. I can say that lag distance is the distance covered during the reaction time. Then what will happen? So the driver saw the obstacle here. And then it took some time to react. And during that reaction time t, the vehicle traveled a distance, lag distance, and that was how much? I told v into t, where t is the reaction time. Then what will happen? At this point, at the end of the reaction times, what will happen? The driver will apply the brakes. So I can say brakes are applied. So now what will happen? Now, after the brakes are applied, the vehicle will decelerate, right? Yes, decelerate. It will decelerate. Why? Because you are stopping the vehicle. So it will decelerate and it will stop here. And this distance is known as what? Your braking distance. This distance is known as what? Your braking distance. So what is, how I can define braking distance? I can say this braking distance is the distance covered after the application of brakes. Yes, this braking distance is the distance covered after the application of brakes. And also I can say that lag distance is the distance covered before the application of brakes. Yes, lag distance is the distance covered before the application of brakes and braking distance covered after the application of brakes. And this SSD, stopping side distance, will be equal to what? That will be equal to lag distance plus braking distance Now we know that when the vehicle is decelerating, okay, when the vehicle is decelerating, or I can say acceleration rate is negative or deceleration, right? Okay, or retardation, I can say that the distance traveled is equal to what? This distance distance traveled is equal to speed square by your 2a. This is equation from kinematics we have studied in our childhood, that when the vehicle is decelerating, so this a is your deceleration rate. This a is what? Your deceleration rate. Yes, the deceleration rate in meter per second square, and this is the speed, the initial speed, I can say. Okay, the initial speed. So s is the distance traveled. So you can see here, when the brakes are applied, the vehicle starts decelerating. And what is the deceleration rate? That is a, and this is the distance traveled, s, or the braking distance. So this s or braking distance is equal to v square by 2a, where a is the acceleration rate or deceleration rate. This deceleration rate is equal to what? It is equal to the g, acceleration due to gravity, which is 9.81 meter per second square, and f, that is your coefficient of friction. That is your what? Coefficient of friction. Now here we will use what? Coefficient of longitudinal friction. Because suppose this is the road, I am drawing the top view. So this is the vehicle going forward. So this is the top view. This is the top view. This is the top view. So when the vehicle is going forward and the brakes are applied, going forward and the brakes are applied, okay, then the friction will be acting in this direction. So this is what? Longitudinal direction. You see, this is the longitudinal direction, this is the lateral direction. So the friction is acting in the longitudinal direction. So I can say this is coefficient of, this is the coefficient of longitudinal friction. This is the coefficient of what? Your longitudinal, this is coefficient of longitudinal friction. Now this coefficient of longitudinal friction, it varies from 0.35 to 0.4. It varies from what? 0.35 to 0.4. And if nothing is mentioned in the question, we'll take this as 0.35. We'll take this as what? Your 0.35. And from this, I get the equation v square by 2gf, where deceleration rate is what? G into f. Now what happens? This equation changes a bit. How? Suppose we have a gradient. This is what? Gradient or slope, I can say. This is gradient, or I can say slope. So if we have a gradient of n percentage, if we have a gradient of n percentage, okay, where the n percentage is the slope. So here the deceleration rate becomes g into f plus minus 0.01 n, and we use the plus for ascending gradient or up gradient, means when we are traveling up a gradient, and we use the negative for descending gradient, okay, or I can say down gradient. And you see, when we have horizontal road, means what? Level road is known as what? Level road, means is not in gradient. So I can say what? Your n is 0 here, the gradient is 0 here, and simply what happens? The a becomes what? This is 0, so simply it becomes g into f. So here you see this equation v square by 2gf, it changes. How it changes? That this stopping side distance is equal to, this braking distance is equal to 2gf. This is for your level road, right? This is for your level road or no slope or no gradient. But it changes to, you see, if you have a gradient, this changes to 2g f plus, because this acceleration rate changes g into this. So in place of f, I'll write down what? F plus minus 0.01 n. Yes, and this equation plus I will use when we have a up gradient and minus I will use when I have a down gradient. Now this equation can also be written in different form. How? You see, this is equal to, in place of this I can write down what? 5 by 8 in capital B. We have already discussed this, that this v is in kilometer per hour, capital B is in kilometer per hour, and small v is in meter per second. Small v is in what? It is in meter per second. It is in meter per second. And I told that if I want to convert this kilometer per hour to meter per second, what I can do? I'll multiply 5 by 18, so I'll get in meter per second. So 5 by 18 into capital B. So this square, because in place of small v I can use 5 by 18 capital B square, divided by what? I can put 2 and I can put this value of g as 9.81, f plus minus 0.01 n. I can rearrange this equation as, you see, v square, this 18 square I'll bring down, so 18 square into 2 into 9.81, and this 5 square I'll bring further down, okay, because you see then it will go up, so become this one only. So this into your f plus minus 0.01 n, and this value approximately is 254. So we get the equation as v square by 254, then f plus minus 0.01 n. Yes, so we got this equation. So this is the braking distance. So if I revise the concept and then we will solve the question, 2 questions I will solve and 1 question I'll give you homework for you to solve, that your stopping side distance is equal to what? It is equal to lag distance. It is equal to lag distance plus braking distance. It is equal to lag distance plus braking distance. Okay. So lag distance is how much I got? This I got is either I can use your speed into time, reaction time, which is 2.5 seconds, or if some other value is given, we'll take that value. Okay. This is in meter per second, or if I'm using in kilometer per hour, 5 by 18 capital V into T. Okay. Same thing, right? And finally the braking distance, either I can use V square by 2G F plus minus 0.01 N, or I can use capital V square by 254. Here I am using kilometer per hour, F plus minus 0.01 N. You get the same value. Okay. Now see, try to understand. This is also in meter. This is also in meter. Some students think that because it is the V is in kilometer per hour, I'll get in kilometer. No. Why? Because you see, when I was deriving this expression, here I have already done 5 by 18 V. That means this value has been already converted into meter per second. Yes. So although capital V is in kilometer per hour, when you have multiplied this 5 by 18, so now it is not in kilometer per hour, that is in meter per second now. It is in meter per second. Okay. So both will give me what? In meter. And this both will give me in meter, because this is also 5 by 18 capital B. So it is also converted into your meter per second. Let us solve 2 questions and then 1 question will be homework. Let us start. So first question is, you see, very straightforward question which is asked in GATE. Repeatedly they ask such questions in GATE. So these are very standard GATE questions. They are very standard GATE questions which they ask in the GATE examination. So what is written here? A vehicle is descending a highway section on a down gradient. Down gradient means what? It is going down, right? Down gradient means what? The slope is negative. Okay, or I can say it is going down, downgrade. So in that it is given 2% and speed is given 80 km per hour. The driver spots an obstruction and applies the brake. The reaction time is given 2.5 seconds, so we'll take that. The coefficient of longitudinal friction is given 0.35, so we'll take that. We are asked to find out the stopping side distance and down to 2 decimal places. So I'll give the information here. You see the n is 2% here, 2. Then speed is given 80 km per hour, so I write down capital B, which is given in kilometer per hour. The reaction time T is equal to 2.5 seconds, and F is given as 0.35. Now, I can find out the lag distance, I can find out braking distance, and I can add them up. So I can say the lag distance will be equal to, what will be the lag distance? It will be simply equal to, you see, 5 by 18 capital V into T. So this will be equal to, you see, 5 by 18 capital V is 80 kilometer per hour and this is 2.5. So I will get a value of, you see, 5 divided by 18 and then multiply by 80 then multiply by 2.5. I'm getting a value of 55.56 meter. So this is the lag distance we are getting. Now the braking distance, if I calculate the braking distance, okay, the braking distance will be equal to, you see, capital V square by 254, okay, is F minus, why? Because this is downgrade. I have told I'll use plus for upgrade or up gradient or going up. I'll use minus when I'm going down gradient. So this will be equal to, you see, I'll put the values. V is 80. So 80 square divided by 254. Then F is how much? F is given as your 0.35 and then you see 0.01 into 2. So 0.02. If I calculate this value, let us see how much I am getting. 80 square divided by 254 divided by 0.35 minus 0.02. I am getting this value as 76.35 meter. So I got the lag distance 55.56. Okay. And I got the braking distance as your 76.35. So I'll add both of them because SSD is what? Lag distance plus braking distance. This is 55.56 plus 76.35. I'm getting a value of 131.91 meter. So this is the stopping side distance. This is the stopping side distance. Pretty simple, right? So lag distance we found out the braking distance and we just added up. Now always they might not ask you the stopping side distance. Another type of question which they ask in GATE exam is they'll provide you the stopping side distance and then they might ask you something else. Like in this question you see they have asked the reaction time. Perception reaction time is same as reaction time. They have asked the reaction time. They have given the speed. You see what is written? The vehicle is traveling at 90 km per hour. The speed is given. Okay. The coefficient of friction is given 0.35. Now it is given that the SSD, the stopping side distance they have given. As I told, always they are not going to ask you stopping side distance. They might give you stopping side distance and they might ask you something else. And in this question they have asked you to find out the reaction time. As I have told, that reaction time is not always 2.5 seconds. It might be different also. So in this question, the stopping side distance SSD, which is equal to how much? It is given to us as 173.52 is equal to, stopping side distance is what? It is lag distance plus your braking distance. So lag distance is how much? It is 5 by 18 capital V into time plus V square by 254. Here it will only be F because you see the gradient is not mentioned here. So we'll take the gradient as 0 here. So we'll get only F. Or I can say F plus 0.01 and N is 0. We'll only get F. So from here you see this becomes 173.52 will be equal to 5 by 18 into time. This is 90, speed is 90 into T plus 90 square divided by 254 into F. In this you see the only missing thing is the reaction time T, and I can easily find out this T. Let me find out this T from here. I'll first find out this value. This is 90 square divided by 254 divided by 0.35. I'm getting this value as 91.11, and when I subtract it from this value, so 173.52 minus this, and then I divide it by, you see this I'll get is 25 actually. So when divide 25, I'm getting 3.29. It is 296. Almost I can say 3.30. So I can mention the answer here is your 3.30 seconds. As I told, always it will not be 2.5 seconds. So in this question it is 3.3 seconds. How we got? Here the stopping side distance was given, and then from there we got the reaction time. In the examination, they might ask you something else also. Like this, see in this question, what is given that a vehicle requires a stopping side distance of your 127.47. So they have given the stopping side distance. Okay, they have given the reaction time also 2.5 seconds. See, they might give you some other reaction time also. Here it is given 2.5 seconds. It might be different also. And then f is given as 0.35. And gradient is not given means what? The gradient is 0. Gradient is not given, you can take that as 0. What is asked? Find out the safe design speed. Means they are asking the speed in kilometer per hour. So you see in this equation you see if the SSD is given, reaction time T is given and F is given, the only missing thing is what? V. And you can solve for V. Actually a quadratic of V will be found because this is V square. Will form the quadratic and you can find out the V here. Okay, so solve this question and give me the answer in the comment section. Okay, so we studied today very important topic of your SSD for your GATE examination. We saw the SSD comprises of what? Lag distance and braking distance. Lag distance formula is what? It is simply 5/18 capital V into T, which is the reaction time and in seconds, and V is the speed in kilometer per hour. The braking distance we got is, yes, the braking distance we got is your V square by 254, we derived this, and then F plus minus 0.01 N. We'll use plus when we have a up gradient, we'll use minus when we have a down gradient. And I told that nothing is mentioned in the question, we can assume N as 0 here, and the SSD stopping side distance is equal to what? The lag distance plus the braking distance. So first question we solved is everything was given. We found out the lag distance, we found out the braking distance, we added them to get the SSD. Next question, the SSD was given, reaction time was asked. So we solved that, and I have a homework question where you have to find out the speed. So please solve the question and mention the answer in the comment section. Thank you very much. See you in the next lecture or some other lecture.